So on this last screencast for Chapter 2, we're going to look at systems and how matter and energy move through systems and how that affects life on Earth and environmental systems in particularly. So there are two types of systems, open and closed. In an open system, matter or energy moves across system boundaries. In a closed system, matter and energy exchanges don't cross boundaries, they stay within the particular system. So an example of the, let me bring that up better, slideshow. Okay, so an example of an open system is the flow of energy from the sun to the earth and how that energy flows around the earth and other energy flows out such as heat energy or reflected light. So that's an open system. Energy is flowing in and flowing out of the Earth's system. On the right here, we have a closed system where matter and energy does not get exchanged within the system we call Earth and its atmosphere. So matter does not significantly change. The amount of matter that's in the system of Earth and air does not change. There might be a little meteor and so forth once in a while, but there's no major input and there's no major output. There isn't a chunk of a continent that goes back off into space. So matter does not flow. We say it cycles. So it might be in, let's say, carbon dioxide and water form, and rearrange and come out as glucose and oxygen. But all of that is cycling within the Earth and its atmosphere within one system. Okay, in nature, systems try to reach a steady state, and that's when the input equals the output. So in this example of a bucket where water is flowing into the bucket at a certain rate, 1 liter per second, and this poor unfortunate bucket has holes in the bottom, so it has an output of water at the same rate, 1 liter per second. So it's said to be in a steady state because the input matches the output. Now, a couple of important points here relating to environmental science. Within steady states are two types of loops, negative feedback loops and positive feedback loops. Let's start with the negative feedback loop. The definition is that a system responds to change by returning to its original state, or at least by decreasing the rate at which the change is occurring. So the example here of a negative feedback loop is a lake. As there is more rain falling, the level of the lake might rise, and as it does, its circumference increases, it gets bigger, and then that means that it has more surface area to evaporate. So as the lake level rises, the surface area increases, and so the level may drop due to evaporation, and then you end up with a lake with a reduced surface area. And because it has a reduced surface area, it has less evaporation, and that keeps it in a steady state in a negative feedback loop. Now, positive feedback loop, the definition is the system responds to change by increasing the rate at which the change is occurring. And they use the example of a population size. So let's say this is a population of rabbits. When you have a larger population, let's say 100 rabbits, they have a certain number of births. If the births result in a population increase, then the increased population, let's say we started with 100 rabbits, now we're at 200 rabbits, so we could have more births. And because of the more births, we could have, again, another increase in population size. So now maybe we have 400 rabbits. And that would continue to cycle around in a positive feedback loop with a more increase in population, more births, and then even a greater increase in population. So there is a bit of an issue with using this example of a positive feedback loop, in my opinion. And so think about nature, think about rabbits on the Cape and think what happens when their population increases. So take a minute to see what really happens in nature when a population enters a positive feedback loop. So I'm going to pause it a minute and give you a minute to think about that. So you may have thought of one or two things that happens when you have a greater increase in something like rabbits. Predators will be attracted to the area, they'll be well fed, and their population will increase, which then will lead to even fewer rabbits. So you have things like foxes and coyotes on the Cape, which would respond to the increase in number of rabbit population size and then decrease their population size. A second thing that happens when you have an increase in population size is you can reach a limit of natural resources. So maybe there won't be enough food, maybe there won't be enough nesting sites, maybe there will not be enough mating sites. And all of these things hold populations in check. So in the natural world, a more typical feedback loop for populations would be the negative feedback loop. There is the exception right now of the human population size, which is increasing in a positive feedback loop. And in a later chapter, we will look at how that loop is working and whether we will, in fact, be affected in the same way other populations are affected and return to a negative feedback loop. Okay, on this last slide for the chapter, we are going to just introduce that natural systems change across space and time. And in the next topic, the next chapter, we will look at ecosystems and how matter and energy interact in those ecosystems and how humans impact those ecosystems. So I leave you with a quote from the book. Throughout Earth's history, natural changes have had large effects on complex systems. But currently, human activities have increased the pace and the intensity of natural environmental changes. All right, so that's a wrap.